we take 10 grams of tin at 95.8 degrees Celsius, added to 105 grams of water at 22.2 degrees Celsius, what is our final temperature? We have the specific heat of both tin and the water. Well, the relationship here is that as we put hot tin into water, cold water, the tin is going to lose heat, the water is going to gain heat. The amount of heat is going to be the same, but there will be a sign change, the direction of heat flow. So we have a negative sign to represent the sign change. So the tin loses the heat, the water gains the heat. Well, we're dealing with a change of temperature with a material, no physical state changes. So this is a specific heat equation. And if we write this out, well, we have the masses, we have the specific heats, we don't have the delta T's. So right now we have two unknowns, one equation, two unknowns, so we can't solve this yet. So I'm going to expand this more. To show the final and initial temperatures. And what saves us in this equation now is that the final temperature is going to become the same. So the tin and the water are in thermal contact with each other, so they'll come to thermal equilibrium, meaning the same temperature. So our final temperature is going to be the same. We have initial temperatures are different. So now we have everything in this equation except the final temperature. And we're going to solve this through. It's a bit of manipulation to solve through, but we can do with this. We can I just reduce the numbers down. So our specific heat of 10.21 times the mass, 10 grams. Specific heat of water times this mass. See, this would be 2.1. Yeah, 439. We can multiply through with the initial numbers. So we've got 2.1 times TF minus 2.1 times the initial 95.8. So we continue working through the numbers. We got minus 49 times the TF, the initial temperature of water, We multiply the 439 by that. That would be negative times negative, so that would be positive. Okay, now we're going to get the temperatures on one side, the numbers on the other side. So move that 9746 over, it becomes negative, so negative 949746 minus 201 equals minus 439 minus 2.1 TF. Combine these numbers. We got 9946, 9947, and minus 441 TF. So final temperature is 9947 over 441 equals 22.6 degrees Celsius. So it was a long, complicated problem here. We had to start off relating the heat loss to the heat gain between the two solutions, and then what allowed us to do it was expanding out the equation to get the final temperature to show up in the equation.